Before we jump in and look at some practice questions, let's just quickly recap some of our basics. We're going to look at some of the definitions, we're going to look at some of the misconceptions, and then we're going to do a little bit of a quiz together to make sure that we know how to apply our laws of exponents. Okay, let's go. Over there, we need to know what this means. It means 2 to the power of 3, where 3 is our exponent and 2 is our base. We need to know that. We need to know that when we refer to the base, what are we talking about? Then what does that mean? 2 to the power of 3 means that 2 is being multiplied by itself 3 times. And in this case, we know the answer. We can evaluate that. It would be 8. Another example, 5 to the power of 4. 5 is being times by itself 4 times, and we can evaluate that. That would give us 625. So we've got our power form. That's just a notation. In the expanded form, they mean exactly the same thing, and there is our evaluated answer. So those three, the power form, expanded form, and the evaluated answer means exactly the same. They just look different. Now, just some reminders. If we just have 7, it means that there is an exponent 1, right? If you have any number and there is just an exponent of, it just means that there is an exponent of 1, if nothing is written down. Then, another reminder, anything to the power of 0 will give you 1. So if you've got any base to the power of 0, it will just be equal to 1. And that can come in very handy when you least expect it. Let's look at some common mistakes. A lot of students think that 5 to the power of 3 means that it's 5 times 3. I see it all the time. That's normally when you're not focusing. It happens and it's okay. But it means that 5 is being multiplied by itself 3 times. So 5 times 5 times 5. And then I've also seen this. 2 to the power of 4 means that it's plus. They're adding the 2s. I don't see that as much, but I have seen it. So I'm just warning you. Now, let's do a quick quiz, and then we're going to do a true and false just to make sure that we can apply our laws and get our basics right, because our practice questions is made up of all the basics. All right, let's look at the first one together. It says that, right, 7 to the power of 3, which is an expanded, not expanded form, that is in exponent form or power notation, and we need to write that in expanded form. So when we do that, it does not mean 7 times 3. It means 7 is being multiplied by itself 3 times. And we answered the question. They didn't ask us to evaluate. They asked us to write it in expanded form. We did that. Okay, second one, evaluate. They want the answer, 9 squared. So they don't want that in expanded form. They want us to get the answer. So 9 squared means 9 times 9. And if we evaluate that, if we get the answer, that would be 81. The third one, 3 to the power of 0. That would be 1. Any base to the power of 0 will give you 1. And then for number 4, convert 8 times itself 3 times into power form. So that will be 8 that is being multiplied by itself 3 times. There you go. Now, some true and false questions. Let's look at the first one. So we just need to comment true and false. Negative exponents. So, if we look at this one over here, it says 3 times x to the power of negative 2 is 1 over 3 times x squared. So maybe pause and write down if you think true or false. You can do all of them or just the first one. I think that you might have said true. But this is false. Let's see why. 3 has got a positive exponent of 1. X has got a negative exponent of 2. So if we want to write our exponents as positive numbers, positive values, the 3 already has a positive exponent. It needs to stay where it is. And that one would move down and be in the denominator. So this would have been true. So this is a common mistake that I see students make all the time, flip the whole fraction. So watch out for that. And the key thing is that 3 has a positive exponent, so we can't just change to the meaning of the sum by moving it down. Let's look at the second one. So we've got 6. We've got 6 times x to the power of 0, which is equal to 6. What do you think about that? Well, we know that 6 is being multiplied by x to the power of 0, and x to the power of 0 gives us 1. So the answer must be 6. It must be true. I think it's a common mistake where students would say false there because they just see an exponent of 0 and they think the whole thing must become 1. Not necessarily. We've got that exponent of 0 that only applies to the x. The exponent of 6 is 1. So be mindful of that. Then number 3. What do you think? True or false? We've got 3 squared times 3 squared times 3 squared times 3 to the power of 0. And it's saying 3 to the power of 6. Well, before we comment, let's actually just work it out. So our bases are the same and we're multiplying. Remember, we're recapping some of our laws of exponents that we use. So our bases are the same and we are multiplying. So that means that we can add our exponents. So it will be 2 plus 2 plus 2 plus a 0, which would be 3 to the power of 6. So I can agree with that. That would be true. Let me just try that again. True. Some of you that maybe said false. If you said false, maybe the, 3 to the power of 0 made you think that the whole thing must become 0. I'm not sure, but I think most of you would have gotten this right. It's just applying our laws. Let's look at number 4. We've got 3 squared times 3 to the power of 4. What do you think? True or false? It is false. If you say true, you most probably looked at it like this. You multiplied your bases. It's so tempting. It's so tempting to multiply those bases. I see students doing it all the time. So in this case, multiplied the bases and then added the exponents. It's not true. Our base needs to stay the same and we add the exponents. So that would have been true. If we just take a little bit of time and we just see why, well, if you first of all evaluate that by using your calculator, you see that you're not going to get to the same answer. But what does that one mean? That one means 3 times itself. Oh my goodness. 3 times itself 2 times, right? And then we are multiplying that by 3 times itself 4 times, right? So what have we got? We've got 3 to the power of 6. It's not going to become 9. All right, so we just used expanded notation there to just illustrate and show that actually that is false. Okay, last one. Here we are dividing. So think about your law of exponents when we are dividing. You can go ahead if you want. I find that a lot of students prefer this, where we just go and write it like that. So that's completely up to you. So what do you think? True or false? I am going to say false. If you said true, I think what you might have done, and let me know if you did something different, 4 divided by 2, which is 2, and then maybe you would have said 6 divided by 3, which is equal to 2. But what does the law of exponent say? It says that if we are dividing and our bases are the same, then our base stays the same and we are going to subtract our exponents, which will be 6 minus 3, not divided. And that will give us 2y to the power of 3. And that's it. So we're just kind of warming up our brains, thinking about the laws of exponent. Now let's jump in and do some practice questions.